Hey guys, today we're going to be talking about the periodic table. So just to kind of introduce it, the periodic table is probably the number one tool that chemists use. It's got a bunch of different answers on it, but if you don't know how to read it, it can just look like a bunch of numbers. So that's one of the things we're going to teach you today, is we're going to teach you kind of some of the important parts of the periodic table. Um, yeah, pretty much it just organizes a bunch of information about the elements, and we'll be asking you to use that information about the elements on some of your quizzes and some of your tests here this unit. So here's what we want you to know is we want you to be familiar with these seven families. You don't have to write them down right now. Just know that we're going to expect you to use the information and kind of know where these families are on the periodic table and how reactive they are. Couple of things you'll notice is that hydrogen and the halogens here in red and orange are both very, very reactive. Also, alkali metals are very reactive, and alkali earth metals are slightly less reactive. Noble gases are very not reactive, so they're what we call inert, which means they don't react. And then we have transition metals, which are fairly not reactive. They can react, but they don't react as much as some of the other metals that we have. So, um, this is what your periodic table should look like. What we're going to work on today is coloring it in. So you'll see up top here, I have organized all the different names of the families, and then I've kind of highlighted shaded in the borders around where those families start and where those families end. Some of the stuff that has been shaded all the way in, like the gray over here and the yellow and the purple, you won't need to do that, but that's just kind of so you know what those groups are, or know that those elements really aren't in a group, but they are, metals or non-metals. Okay, did you know that this is actually how the periodic table looks? Yeah, so if we go back over here, these lanthanide and actinide series in pink here actually kind of get put in right over here towards the bottom of the transition metals, which creates a super, super long periodic table. So just for the sake of making it nice and short, we kind of squish that part and move it down below so that it's kind of out of the way, and that so the periodic table looks a little bit nicer. Okay. One of the things you should already know is how many valence electrons each element has. Remember, that's based on the columns. So in column one, everything has one valence electron. In the second column, everything has two valence electrons. And then they have charges of +1 and +2. You should know that. You should have a copy of your own periodic table and have that written down. What we're going to do now is we're going to use these terms groups and periods. So I want you to know that a group is what we call a column, something that goes up and down like this. So for example, we wouldn't call this column one, we would call this group one. There's a total of 18. If you kind of name each column, you get a total of 18. These columns 3 through 12 here are the transition metals, and they don't really have valence electrons. I guess they technically have two valence electrons, but they behave weirdly, so we don't really give them, we can't say that they all have the same charge because they all have a bunch of different charges. Families are just kind of one or more parts of a group. We'll shade those in. That's what I showed you earlier. And then a period is a horizontal row. So as you go across the row, the properties that elements have become totally different. As you go down a group, all the properties stay the same. For example, in group one, they all have the same charge of 1 plus, and they all have one valence electron, and they also all react to halogens in the same way, for example. So yeah, kind of fun. I would write down group and period, and I would also add to your periodic table the numbers 1 through 18 for groups and 1 through 7 for periods. And then if you didn't have the valence electrons written on your periodic table or the charges, I would add those in. I remember it's 1 plus 2 plus for 1 and 3 plus for 1, 2, and 13, 4 plus for 14, and then 3 minus 2 minus 1 minus for 15, 16, and 17. So hopefully that makes sense. Cool. Before the periodic table happened, it was a mess. And then there was this guy, his name was Dmitry Mendeleev. He came up with a way to kind of organize the periodic table. It wasn't perfect. Here's kind of what his periodic table looked like. I tried to kind of make sense of it, but it still wasn't the best. But he did kind of come up with some ideas that we were able to then kind of run with, and we came up with the modern periodic table from this guy named Moseley. You don't need to know that. It's just more of a fun fact. What you do need to know though is groups versus columns. So you should already have this written down, or sorry, groups versus periods, aka columns versus rows. So you should have your groups and periods written down. You should also know that elements in the same group have similar chemical and physical properties. Um, that's because they have the same number of valence electrons. That's because they'll form the same kind of ions. So again, remember to have the charges and the number of valence electrons written down. Okay, now we need to talk about families. Families are where you're going to actually color in the periodic table. So get excited for that. Families are, it could be one column or it could be several columns put together. Kind of like how your family has a name. Like, for example, my family's name is Smith. Your family has a name, not just a number. So we've given families a name just because they all have similar characteristics in elements as well. So there's little element families. These are the families. You've seen them before. So we're going to go through them one at a time and kind of show you where they are on the periodic table. This is what your periodic table should look like when we're done. So keep that in mind. Maybe you want to stop right now and color it in if you're into that. Otherwise, we're just going to go through them one at a time. So we'll start with hydrogen. Hydrogen is right up at the top here. There it is. It belongs to its own family because it's so unique. It's a super reactive gas. It's involved in the Hindenburg explosion. Hydrogen was used as a gas for blimps until they realized it's a little too reactive, but it was very light and very plentiful. So that's kind of nice. Up next, we have what we call the alkali metals. Alkali metals are in the first column. They're very reactive metals, and so we won't ever see like a thing of sodium, Na, for example, just in the world. Usually sodium's combined with something, like for example, chlorine or something else. Next up, we have the alkaline earth metals. So notice the difference here, alkali metals versus alkaline earth metals. Very similar names. Alkaline earth metals is the second column. So the way I think of it is alkali always comes first because it's fewer letters, and then alkaline earth comes second because it's more letters. They all have two valence electrons. These are things like magnesium, calcium, different stuff that you would kind of see in your body. They're important mineral nutrients. So yeah. The halogens are all the way over in column 17 over here. They are very reactive, and they actually exist in the world as diatomic atoms. So for example, you wouldn't see just one chlorine ion, one Cl ion floating around. There would be two of them stuck together. Or you wouldn't see one fluorine ion floating around, you'd see two of them stuck together. Chlorine's used in pools. Iodine is used to help treat wounds before surgery. And fluorine is used in your teeth, fluoride. So yeah. Noble gases, the important thing to know about noble gases is that they are very unreactive. They do not react with stuff, but they are used in signs. So if you excite them super, super high, they glow, which is true of most gases, but they do that. Up next, we have transition metals, and these are, I would say, metally metals. These are what you think of when you think of a metal. They're used in construction or jewelry. You got things like silver, gold, platinum, all in there, but also things like iron, copper, zinc, other things like that. So yeah, transition metals. Last thing we have are the metalloids. These are 7 specific metals that you'll notice kind of form a little like stair-steppy path on the periodic table. Metalloids are kind of a mix in between metals and nonmetals. They have properties of both. Sometimes we'll refer to them as semiconductors. So maybe you've heard that term before. They're used a lot in like electronics and circuits and stuff. So for example, silicon is a really common, number 14 here in the periodic table, Si, is a really common semiconductor that's used a lot in computers, hence the term Silicon Valley for the area where there's a bunch of like tech companies and stuff. So yeah, metalloids. Okay, just so you know, there are certain areas that are not outlined. Like we've got this little chunk here below the metalloids, we've got this chunk above the metalloids, and then we've got these two columns below. Now, these do have names, but I'm not going to expect you to know them, other than the stuff below the metalloids are metals, and the stuff above the metalloids are non-metals. That's helpful to know. You could get even more specific and say that like group 14 is called the carbon column, and it doesn't really matter. And then below here, these two little giant long columns or rows are called the lanthanide and actinide series. These are super heavy metals that don't really come into play a lot in the world of chemistry. They're more used in like bombs and stuff, like nuclear bombs. I don't know. So yeah, this is what your periodic table should look like in terms of coloring. You don't have to use the exact same colors I used, but if you're on Notability, I don't know, it's maybe easier to just use the same colors I use. And then remember, here are the valence electrons. Remember, you should also have charges in here on everything. There's a bear up there as well. There have been a couple bears in the PowerPoint. I wondered if you saw those. Okay. Last thing I wanted to just talk about is metals, metalloids, and nonmetals. So everything in yellow here, everything kind of to the right of the metalloids, those are all nonmetals. So any noble gases you have, and then kind of the other nonmetals, but then also hydrogen. Hydrogen's also a nonmetal. Everything in blue is a metal, and then these green things are the metalloids that kind of separate the, nonmetals from the metals. So yeah. Okay. There's a total of 89 metals and only 20 nonmetals. So most of our elements are actually metallic, which is kind of cool. And then you've got those 7 metalloids kind of in the middle there. So yeah, total of 118 elements on the periodic table. We won't expect you to know all of them, just pretty much the first 20. You're going to want to have more or less memorized. And when I say memorized, you should know that Li stands for lithium, or K stands for potassium, or Na stands for sodium, that sort of thing. Cool. Well, thanks, guys. Hopefully, you know a little bit more about the periodic table. Thanks for tuning in. Have a great rest of your day.